Welcome everyone to today's lecture on the topic of motion in a vertical circle. So, first of all, we are going to continue with some problems on conservation of mechanical energy. So, here are the problems. So, we read in conservation of mechanical energy that mechanical energy is made of primarily two components, that is potential energy and kinetic energy, and then entirely of potential energy and kinetic energy. And the potential energy is divided into various parts like spring energy, gravitational potential energy, and electrostatic potential energy. So, let us do some questions to build a greater grip on this idea. So, the first question which we have is that of the potential energy of a particle of mass 1 kg. It obeys a law that the potential energy of the particle is u 3x plus 4y. If the particle is at rest at 6 comma 4, you have to find the acceleration of the particle. You have to find the speed of the particle when it crosses y-axis and the coordinates of the particle. So we know the potential energy of the particle to be 3x plus 4y. Now what does this mean? This means that the potential energy of the particle is a function which obeys, which is governed by the x and y position of the particle. So this clearly means that if we want to define, let's say, difference in potential energy of the particle between 2 points, uh, let's say the points which we are considering here only. For example, the points 6 comma 4 and uh, let's say the point where it crosses y-axis, or let's say any other point at its path, wherever it crosses y-axis. So when the particle is taken along some straight line path from 6 comma 4 to that particular point, and then along some other path, it can be taken some along some other path also. Then also the change in potential energy of the particle associated with that particular force would remain same. So that means it becomes a conservative force. So we can apply conservation of mechanical energy. So you have to find the acceleration of the particle. That is the first point. So the formula for acceleration uh, of the particle would be minus du by dx is equal to the force of the particle in x direction, and minus du by dy would be the force of the particle in y direction. So the potential energy of the particle is 3x plus 4y. So differentiating it with respect to x, we would get fx is equal to some minus 3 newtons. And similarly, fy would be some minus 4 newtons. The particle is of mass 1 kg, so these are accelerations also minus 3 and minus 4 meter per second square. So that means the particle which started from some point 6 comma 4 somewhere here, it is going to take some path where its acceleration is minus 3 and minus 4 meter per second square, and it's going to uh, cross the origin. So the first part is, what is the acceleration? The acceleration is nothing but minus 3, that is the acceleration in x direction, and minus 4, that is the acceleration in y direction. So next, what is the speed of the particle as it crosses the origin? As it crosses the y-axis, not the origin. So as it crosses the y-axis, can we find the coordinates of the particle as it crosses the y-axis? So we can do it in this way, that what would be the direction of motion of the particle. So if we want to find that, we can take the ratio ay by ax. So that is some 4 by 3. So from the point 6 comma 4, we draw a line of slope 4 by 3. So that would be somewhere something like this, that y minus the y coordinate, that is 4, divided by x minus some x coordinate, that is 6, is equal to 4 upon 3. So this would be straight line in which the particle would be going. So when the particle crosses y-axis, when the particle crosses y-axis, x coordinate would be 0. So the y coordinate would be 8, as x would be 0. So this would be minus 6 into 4 by 3. So minus 6 into 4 by 3, that would be minus 8 plus 4. So this would come out to be minus 4. So that means the particle would cross the y-axis somewhere here at some minus 4 coordinate. So what would be the speed of the particle at that point? So for that we can use conservation of mechanical energy, which says that the potential energy of the particle at some initial point plus the kinetic energy at some initial point is final potential energy plus final kinetic energy. The initial potential energy of the particle is given by 3 times 6 plus 4 times y, 3x plus 4y. Y coordinate is 4. Initial kinetic energy is at rest. Final kinetic energy of the particle is at y equal to minus 4, would be 4 into minus 4 plus the final kinetic energy. So this would come out to be some 18 plus 32 joules. So this would be equal to half mv square. So this comes out to be 100 equal to mv square. So the velocity of the particles would be some 10 meters per second. Next, we are asked what is the position of the particle when the particle is at when the time is 1 second. So what will be the position of the particle after 1 second has passed? So this we can calculate using x is equal to 6 minus half acceleration in x direction is minus 3 into 1. So this would be 6 plus 1.5. So that would be some 7.5 meters. So this is actually a plus sign plus minus 1.3. So this is actually 4.5 meters. And y coordinate is initially the y coordinate is some 4 plus half, uh, and the acceleration in y direction minus 4. That is 2 meters. So that means the coordinate of the particle at some 1 second would be uh, 4.5 meters, comma 2 meters. So let us move ahead to the next question. So the potential of the particle is some k x square plus y square, where k is greater than 0. The particle is at rest at 3 comma 3. The particle begins to move towards 1 comma 1. Find its kinetic energy when it reaches 1 comma 1. So there are the options which are given: 8k, 24k, 16k, or 0. What would be kinetic energy? Again, we will use the same idea that the potential of the particle is a function of uh, x and y. So it's a conservative force with which we have associated u. So we can apply conservation of mechanical energy. So the potential energy of the particle at 3 comma 3 would be some k into x square, that is 9 plus 9. That is the initial potential energy of the particle. X square plus y square. Initial kinetic energy of the particle is 0. Similarly, finally, the potential energy of the particle is simply 2, and final kinetic energy we have to find. So the difference of these two values is simply 16k, as we can see. So that would be the final kinetic energy of the particle. So that means 16k would be the correct option. Again, this third question is an interesting one. And we have the function of force of the particle as a coordinate of x, and only one dimension of force is given. As you would have seen in previous examples, we were dealing with two-dimensional forces. But it's not necessary that we have to think that if the force is in two direction, then it's conservative or not. It does not work in that way. The conservative forces are simply governed by the fact that if the work done by the particle, by the force or the particle between 2 points is independent of the path. So that can happen in one dimension also. So this is the force of this kind only. It's the conservative force. So we have to plot the ux curve given that uu is 0. So this is a bit of a mathematical question. We know that du by dx is equal to minus fx. So that force is given to us as a minus kx plus ax cube, minus kx plus ax cube. So we have to take the integration. We have to integrate it to find u. So that would come out to be some kx square by 2 minus ax की power 4 by 4 plus 0. Since we know that the constant of integration is 0. So if we want to plot this, how do you plot it? So that is the point. We want to learn how to plot such a graph. So to plot any curve which is having higher power than three or four powers, we have to first differentiate it. So that is already given to us. So we didn't even need to calculate the potential energy even here. The differential of that expression is given, and if we equate that expression to 0, we will get the points where the slope of the curve is 0. That means at x equal to 0, the curve is 0. And at 2 points, somewhere here and somewhere here, if we put this equal to 0, you would get those 2 points. That's for you to find. And somewhere here and here, we'll get the 0 points. So let us find them. These values would be some k equal to ax square. So that would be x square root k by a plus minus, right? Plus minus k by a. So if you put the value of this square plus minus k by a somewhere here, so it would yield some positive value. So these values are the value of potential energy on the y-axis. So since the curve is polynomial in nature, it would go to negative infinities if the value of x is much higher. Since x has having power 4 with the negative sign, it would mean that for positive and negative infinities, it would go to negative infinity. That means the curve is starting from somewhere here, and it would go, it would get to zero slope over here, again to zero slope at zero, again would go to the slope, and again back to negative infinity. So this is the kind of the curve which would be represented by this u function. So this is a interesting question. All these questions have been asked in JEE Advanced. Next, we want to learn what is motion in a vertical circle. So motion in a vertical circle can be uh, a very common problem. Again, it's a special case since when a particle is connected to a string and it is whirled in a circle, so what are the forces acting on the particle and how is it special? So there are tension force acting on it, gravitation force acting on it. The force are acting only two, but the tension is always perpendicular to the motion of the particle. So that means when external forces are present, that is, here we are considering the mass and earth system. The external forces are the tension force. But the tension forces are there, but they do not work because we know that the centripetal forces do not work when a particle is going in a circle. So that's why we can apply conservation of mechanical energy. And it is a very common case which is asked in exams. So first of all, we want to find what is the minimum velocity with which the particle is at the bottommost point, that is x, which it requires so that it is able to reach the point z. So what would be the minimum possible velocity? We know that if we have some high velocity, then the particle would be moving in a vertical circle quite easily. But how do we take into the account the cases when the particle uh, is having just sufficient speed? So what we do, we take the most critical point in our system and we study that. So this is in fact our approach in a lot of questions. That is the what is the most critical point in the system. We try to identify it. So our system in this case is the mass and the Earth system, and the critical point is the highest most point. If the particle is able to cross the highest most point with some sufficient speed, then we don't have to worry about the whole circle. What we have to focus is on, it must have some sufficient speed on the highest point. Maybe it is zero, but we want to evaluate that particular point. So let us try to study what is going on at the highest most point. So when the particle is at the highest point, what are the forces acting on the particle? The gravitational force would definitely act. So can the gravitational force be sufficient to keep the particle moving in a circle of this L radius? That is the point which we are having. So the answer is yes. We can have gravity acting as a centripetal force in this case. So what would be the velocity of the particle in that point? So that would be some mvz square by L. So from here we can find the value of vz. It would be some square root gm. So this is the velocity required at the highest most point for the particle to cross this particular point with the minimum speed. If the velocity of the particle is less than this, then the particle would slack off. And if the particle's velocity is more than that, then it would continue going. But this is the minimum possible speed required at the highest point. And one more interesting thing, what would be the tension in the string at the highest point? Would the string be gone? Well, the answer is no, the string would be there, but the tension acting in the string would be zero, since we don't require the tension at all. What we want is the most critical case for the particle to go this complete circle. So if some tension is there, it would again add in this equation and it would increase the value of Vz, which we don't want. We want the minimum possible value of Vz. So we eliminated tension altogether in our equations. And only gravitational force acts at the centripetal force at the highest point. And this is the motion in the vertical circle in its summary. And what is the minimum speed required at the highest point and the bottommost point? So these are the points which we're considering, points y and points x. So what would be the speed of the particle and x and y points? So let us calculate them. quite quickly using conservation of mechanical energy. So even the value of tension is varying in throughout the motion. We don't need to worry about what is the work done by tension since it is acting perpendicular to the motion. So the velocity of the particle is bottommost point Vx squared mvx squared by 2 plus the uh, potential energy at that level, that is at the bottommost point 0, is equal to the potential energy, it is equal to the kinetic energy at the highest point, that is mvz square by 2. So that would be some m by 2 gl plus potential energy of the particle at the highest point, that is 2 mg. So the particle would try to gain this potential energy and gain this potential energy, and not try to, it would actually be having this particular potential energy 2 mgm, since that is the distance from the bottom. So if we solve this, we'll get the value of Vx. It would be some root 5 gm. Similarly, in this circle, let us say in this circle, this is the velocity of the particle at this point, velocity of the particle at the point at this point Vz, velocity of the particle at this middle point. So this is left to you as an exercise. The value of this Vy would be some root 3 gm. You can find it using potential energy and kinetic energy equation. So next, let us do some questions. So this is written here. Speed of the particle required x necessary for the particle to cross z with square root rg, that is the minimum possible speed, is square root 5 rg. Similarly, speed of the particle required at y necessary for the particle to cross z with square root rg is equal to square root 3rg. So this is what necessary conditions mean. Necessary conditions mean that if we want the particle to have square root 3 rg speed, then we must have square root 3 rg. So now we have a question of more than one choice options. We have to mark the correct option. So the speed of the particle at x is less than or equal to square root 2 rg. It would oscillate about the mean position. So this is a correct option. I'll show you how. The question is, if we have a particle connected to a string and we give it a velocity v less than or equal to square root tgl, what will happen? So square root 2gl, as you might have imagined, if the velocity is square root 2gl, the particle would go here and it would stop. It would not move. So this is by easy calculation you can figure out that what is the velocity of the particle at that point. It would z0. So the particle would come back, return. It would come back to this point x and would keep on moving, and it would go over here and again stop moving. So it would complete a oscillatory motion about its mean position. So that is the first point, that the particle would oscillate about mean position. This answer is right. If the speed of a particle is less than square root 5 rg, that is less than the speed required to keep the particle moving in a circle, but more than square root 2 grg, it would leave the circle after crossing point 1. So this is what will happen is that the particle is going in a circle. Now, when the particle is the bottommost point, it is having speed less than root 5 gl. That means if a particle were to reach here, it won't move further. It would stop moving in a circle and more than root 2 gl. That means the particle is definitely going to cross point y. So what is going to happen, do you think? So that is important. We need to think in such a situation which are not regular. We can evaluate a lot of values using equations, but what we need to develop is thinking in situations which are having some variation That is, the velocity can vary between these two values. So what are those values and what will happen in between? So the particle is going to cross by, that we are sure of. If the particle speed was less than root 2 gl, it wouldn't have crossed by. But it has crossed by and not going to cross z. So if we know that, then it is pretty easy to decide, right? Particle is going to cross by and not cross z. That means it is going to leave the circle at some point and it is going to become slack. The string will become slack and it would fall down. So this is one of the questions. Actually, one more question which uh, begins from this particular point, that how would be the particle moving? The particle would be moving a parabolic trajectory. So this would happen. So this is what was asked from us. That is, the particle, it would leave the circle. So this option is correct. If the speed of the particle is more than or equal to this, it will complete the first circle. This is right. If the string and the motion is replaced by rod, zero speed required at highest point. So this is also correct. If we have a rod instead of a string, we actually don't need speed at all at the highest point. So the what would happen is that the particle is having some non-zero speed just before it reaches the highest point. It is having some slow speed, and just as it reaches the highest point, it is having very minimum speed, very close to zero. So it reaches the highest point and it just crosses over. It's because the rod cannot slack at the highest point. So that's when no speed is required. In fact, the rod will be having some compression equal to mg because of the mass and weight of the string that is balanced by the rod. If we were to draw the diagram, there would be some normal reaction on the rod and would be gravitational force on the particle. So the compression of the rod would be equal to mg. So no speed is required as highest. First question. Next question, we have a circular track, and in that we have a particle with the speed v at the bottommost point. We have to find the point where the angle where the tension in the string is mg. Tension in the string at that given instant is mg, where m is mass of the particle. So how we'll do it? So at any given point, can we calculate the tension in the string? We know speed of the particle. It is v. Uh, so at what point would the tension in the string become equal to mg? So v is given to us as root gl. This is what we know. V is given as root gl. So can we calculate the tension at the bottommost point? So let us try to find it. Gravitational force is downward direction, tension is upward direction. Tension minus mg is equal to mv square divided by L. So tension would be equal to some 2 mg at the bottommost point. So as it moves ahead, tension would decrease. This is T dash, just for clarity. Mg, some angle theta. So we are saying that tension minus some component of mg, that is cos theta, would be equal to mv1 square divided by L. And this tension has to be equal to mg as per our condition. So that means mg into 1 minus cos theta has to be equal to mv1 square by L. So you would get a point for guessing which other equation which we have to use. The answer is we have to use conservation of mechanical energy. Because the particle is moving, it is going to lose some velocity. So this distance is the distance which is lost or gained by the particle, height gained by the particle. So this would be some L 1 minus cos theta. This distance is going to be, as this distance is L, radius is L, this is L cos theta. This complete distance is L, so this distance becomes L1 minus cos theta. So L1 minus cos theta into mg. This is the gain in gravitational potential energy. So this comes at the cost of kinetic energy. That is m by 2 v square minus v1 square. So if we want to replace mg1 minus cos theta, we can do it. So it would become mv1 square by L into L is equal to m by 2 v square minus v1 square. So that means 3v1 square is equal to v square, or v1 is equal to v by root 3, or root gl by 3. So from this we can also find what is the value of theta. But this was the question that you had to evaluate the tension in the string, you have to use the conservation of mechanical energy, and you have to draw an FBD and think in terms of components, that what is the component, how do we do the equation, and how we solve it. So this is a pretty good question. Next, we have a block. Now the block is coming down an smooth surface, so a smooth incline, which is a curved surface, and it ends up in a track of radius small r. So a small r is related to h as h equal to 5r. So we have to find the net force on the block at q. And the next part is, from what height h should we release m, so that when it is at r, it exerts a force mg on the track. So this is the track actually of some radius r. So let us do this one. So from conservation of mechanical energy, we can directly say what is the velocity of the particle of the block at this point. Let's say this velocity is v. So this height is r, and the height it was released from initially is 5r. So the loss in gravitational potential energy is 4 mgr. That is the difference of the height 5r and r. This is equal to gain in the kinetic energy, half mv square. So that means v square is equal to 8gr. This can be used to find what is the normal reaction acting on the block at that time. The gravitational force is going to be mg. The normal reaction would be providing the centripetal force required uh, to keep the block going in the track. And this is actually what we want to learn. That here the string is not there, right? The particle is moving, the block is moving in a circle. But instead of string, we have normal reaction. The normal reaction also works in the same way. So the normal reaction is going to provide the centripetal acceleration, that is mv square by r, and we already know v square is 8gr, so it comes out to be 8 mg. So this is normal force, and we have to find out what is the net force acting on the block at that point. So the net force acting would be square root n square plus mg whole square. So this would come out to be some square root 65 into mg. So this would be the net force acting on the particle. So, with this, we'll be ending this lecture. And thank you for joining, and have a great day.